So our next topic is all about collapse mechanism. A statically determinate beam will fail if one plastic hinge develops. If a simple beam is loaded with a concentrated load at its midspan, and if it is increased until a plastic hinge is developed at the point of application of the load where maximum moment occurs, this will cause an unstable structure wherein further increase in load will cause collapse. So yung tendency kasi ng beam natin, so let's say we have a loaded na uniformly distributed na W sub U. So for this mechanism, yung nangyayari is if we were going to apply a certain load, so usually yung mga loads natin na yan, so let's say we have a concentrated load acting on the midspan. Tapos simple beam to. So nangyayari yung mga loads natin, that is P. So habang tumataas yung value ng P natin, nagkakaroon tayo ng mga plastic hinges. For this example, kapag tumaas yung value ng P natin, let's say from P, tumaas yung value niya, nag-increase siya, hanggang sa marating niya yung load natin na ultimate load, which is P sub U. So usually, when we are considering collapse mechanism, kinukuha natin yung mga ultimate loads natin. So dealing with ultimate load, nawawala na tayo sa allowable stress design. So for this example, sa collapse mechanism, nasa LRFD design na tayo. So, usually, di ba, kapag meron tayong W section, yung nangyayari on the elastic section, kapag meron tayong diagram on the elastic section, is paganto. This is the stress distribution kapag W section. So, under this, ito yung tinatawag nating ASD. Pero kapag in-increase natin yung value ng mga loads natin, so, yung tendency dito, yung bending stress natin, that is less than 2F1. So, kapag in-increase natin yung mga loads natin, siyempre, i-increase yung value ng maximum moment natin, tataas yung value ng Fy natin. So, for this example, kapag tumaas yung value ng P natin, hanggang sa makaabot siya sa ultimate load, so, nangyayari is, nagiging ganito yung stress diagram natin. Wherein, kapag yung F natin na to, that is equal to Fy. So, yun ang nangyayari is nade-develop yung plastic analysis. So, for this plastic analysis, LRFD approach na tayo kasi yung mga loadings natin, naka-factored na sila. So, for this example, kung meron tayong plastic analysis, siyempre meron tayong tinatawag na plastic hinges. So sa mga plastic hinges na yan, doon tayo nagkakaroon ng collapse mechanism. So for this example, so nagkakaroon daw tayo ng collapse mechanism kapag concentrated load, doon mismo sa ilalim ng concentrated load natin. So for this example, kung meron kang given na nominal load, so kailangan mo pa siyang i-factor para maging ultimate load. So usually kasi, sa steel natin, under the plastic analysis, yung beam natin, it will going to collapse at this point. Ayan. So magkakaroon tayo dito ng plastic hinge. Tapos, etong dalawa natin, eto yung tinatawag nating real hinge. So, nagkakaroon tayo ng plastic hinge kasi nga nangyayari is masisira etong beam natin ng pagganito. So, meaning to say is ma-UUP siya. So, for this example, yung kinagandahan lang ng mga steel beam natin, ma-UUP siya in this form. Hindi katulad ng mga RCD na kapag nayupe is masisira muna etong sa tension side niya. So, mas maganda yung kung paano magko-collapse yung steel beam natin. For collapse mechanism, under lang to ha, sa steel beam. So, kapag concrete beam, ganito siya, magde-deflect, ganito siya masisira. So, for this, yung nangyayari is, yung mga fibers ng beam natin, so let's say, no, meron tayo dito, ito yung mga steel beam natin. So, yung nangyayari is, nagkakaroon tayo dito ng plastic hinge. Tapos, siyempre, nasisira ng pagganito yung beam natin. So, yung tendency niyan is, eto yung, dito nag-e-exist yung plastic hinge natin. Tapos, from this hinge, nandirito yung tinatawag nating plastic moment. So, ganyan masisira etong steel natin. So, for this collapse mechanism na topic, we will going to discuss lahat ng loadings natin. So, we have a uniformly distributed load, concentrated load, continuous beam, and at the same time, prop beam. So, i-discuss natin lahat. So, for this example, no, nagkakaroon tayo ng plastic hinge under sa concentrated load natin. So, yung collapse mechanism, so ina-apply natin dito yung tinatawag nating virtual work method. So, for this example, very applicable yung virtual work method, which is the external work is equals to the internal work. So, for this example, yung ibig sabihin lang naman yan is that will become yung PU multiplied by Y kasi nagkakaroon tayo dito ng deflection. So that is yung tinatawag nating Y. Tapos from this one, since yung concentrated load natin acting at midspan, etong value na to is theta. And yung value dito is theta. Tapos, mangyayari niyan is magkakaroon tayo ng mga rotation dito. So, for this one, at the plastic hinge, magkakaroon tayo dito ng 2 theta. Kasi nga yung mangyayari niyan is meron tayong theta dito at saka theta dito. So, pag-a-add natin yung dalawa, meron tayong 2 theta. So, for this one, PUY, yun yung external work natin. Tapos, yung internal work naman is yun yung nasa beam natin or acting on the plastic hinge. So, that is equal to yung MP natin all over summation lang lahat ng mga rotations natin. So, for this one, meron tayong PUY is equals to plastic moment. So, pag-add natin yung lahat. So, pag-add natin silang lahat. So, we have 2 theta plus lahat ng rotations natin. Lahat ng theta natin, i-add natin. 2 theta plus theta plus theta. But, in this case, kapag uniformly distributed load at saka concentrated load, the value of your theta, sarili hinge. Sarili hinge lang ha. So, may tayong plastic hinge at saka sarili hinge. So, yung value ng theta natin, sarili hinge, always equal to 0. So, yung value ng theta natin dito is equal to 0. The value of your theta is equal to 0. So, lahat ng mga rotational natin, so, lagi natin yung ina-add. So, 2 theta plus theta plus theta. Kaso, in this case, nangyari is, yung value ng theta natin is equal to 0. Kaya, eto na lang yung mako-form natin. So, dealing with collapse mechanism, so, meron pa rin tayong ditong analysis sa plastic design. So, dito pa rin, under pa rin dito nung plastic analysis natin na discuss natin sa previous discussion. For us to further understand, so, i-apply natin itong principles na yon dito sa sample problem number 1. For sample problem number 1, a simply supported beam has a span of 1.8 meter and a rectangular section of 25 mm by 50 mm. So for this one, we have 1.8 meter. And kapag sinabi natin dito, so usually, kapag sinabi niya una, that is yung base natin by yung height natin. So we have 25 mm and 50 mm. If the beam is uniformly loaded over the full span, determine the ultimate load, WU, that will induce a plastic hinge at midspan. So usually nagkakaroon tayo ng plastic hinge. Kapag nagkaroon tayo ng plastic hinge, yun yung magkakaroon tayo ng collapse. So for this example, yung collapse natin or the plastic hinge will happen at the midspan. So mangyayari niyan is yung beam natin magko-collapse yan sa midspan. So yung midspan niya, that is equal to 0.9 kasi 1.8 divided by 2. So that is equal to 0.9. Ayan. So for this one, so the distance natin na to, that is equal to 1.8. Ayan. So magkakaroon tayo dito ng plastic hinge. So for this one, meron tayong plastic hinge. And eto namang dalawang eto yung tinatawag nating rib hinge. So for this, dahil nga meron tayong plastic hinge, siyempre meron tayong deflection dito. So eto yung tinatawag nating Y. So because nagkaroon tayo ng collapse, so yung mangyayari niyan is magkakaroon tayo ng rotation dito. So since nasa midspan to, yung length natin dito is 0.9. Tapos dun sa kabila is 0.9. So we will have a rotation dito na theta. Dun sa kabila, that is also theta. Kasi parehas lang naman yung value niya. Kasi yung length niya, parehas lang naman. Kasi nasa midspan tayo. So yung mangyayari niyan, yung value natin dito, that will become, so meron tayong theta dito sa kabila. Tapos sa kabila din meron. So that is equal to 2 theta. So ngayon, we're going to apply the virtual work method. So virtual work method states that the total external load times the average deflection of the mechanism, so that is yung TU, Y. So total load times yung average deflection is equal to the internal work absorbed by the hinges or the sum of plastic moment at each plastic hinge multiplied by the angle through which it works. So mangyayari yung multiplied by the plastic moment capacity multiplied by the summation of the angles. So for this, external work is equals to internal work. So yung tendency nito, mangyayari niyan is magkakaroon tayo ng point of collapse in this one. So yung loadings natin yan, it will be divided into 2. So yung mangyayari, in computing for the value of your PU, so yung mangyayari yung WU natin, despite and in spite of the distances, mangyayari niyan is madidivide into 2 etong load natin. So yung una is mapupunta sa side na to, and yung pangalawa naman mapupunta dito sa kabilang side. So yung mangyayari in computing for the value of your PU, so that is equal to WU times yung buo nating length, that is L, multiplied by 1 half. Kasi nga, kung makukuha natin yung buong concentrated load, that is WU times L. Kaso mahahati, kasi nga nagkaroon tayo ng plastic hinge dito. So, yung kalahati mapupunta sa side na to, tapos yung remaining sa side naman yun. Kaya, nag 1/2 dito. Multiplied by y is equals to the moment, tapos yung mga theta natin. So, we have here na 2 theta at plastic hinge, plus theta, plus theta. So, yung tendency lang dito kung ilalagay natin, we have WU, the value of your L is equal to 1.8, 1/2. So, yung value ng Y na lang natin, yung problema natin. So, for this example, we can use yung formula natin dito na, or the function na tangent. So, we have tangent theta is equals to opposite, which is equal to y, all over yung length natin na 0.9. Kaso, sobrang liit lang nung value ng angle natin. That's why, sobrang liit lang ng angle natin na yan. That's why tangent theta is equal to theta. So for this one, so yung theta natin, that is approximately equal to theta, is equals to y over 0.9. So the value of your y is equals to 0.9 theta. So yung y natin, that is equal to 0.9 theta. Kaso for for uniformly distributed load, so yung mga real hinge natin, so meron tayong real hinge dito, so yung value ng mga theta na yan is equals to 0. Meron lang tayo sa plastic hinge. Ngayon, nag-equal to 0 lang yung mga real hinge natin kapag uniformly distributed load. At saka, kapag meron tayong uniformly distributed load. And at the same time, kapag yung application ng concentrated load natin nasa gitna. So for this one, since kung kukunin natin yung PU natin dito, acting siya at midspan. So yung mangyayari, yung value ng mga angles natin dito is equals to 0. So for this one, we have MP 2 theta. So makakancel lang yung value ng theta natin. So makukuha natin yung W natin in terms of MP. So, W in terms of MP, that is equal to 2.47 MP. Ngayon, yung plastic moment capacity naman natin, makukuha naman natin yan using yung principle natin sa plastic analysis. So, for this one, so let's solve for the value of your MP. So the value of your MP, that is equal to Fy multiplied by the plastic section modulus. So kunin muna natin yung value ng plastic section modulus. So that is equal to, since symmetrical lang naman etong beam natin, so yung mangyayari yung elastic neutral axis and the plastic neutral axis, magko-coincide lang yan. So yung tendency natin yan, we're going to consider yung nasa taas natin tsaka nasa baba na area. So we will have, let's consider muna yung nasa taas natin. So we will have 25 multiplied by 25 multiplied by kalahati ng 25, so that will become 12.5. So gagawin natin dito, ita times 2 na lang natin siya. Since parehas lang naman etong sa top natin at saka dito sa bottom. So the value of your plastic section modulus is now equal to 15,625 millimeter cube. So for this, makukuha na natin yung value ng MP natin. We have a value of Fy, which is equal to 250. The value of your Z na 15,625. So, makukuha na natin yung plastic moment capacity natin, which is equal to 3.91 kilonewton meter. So, gamitin lang natin etong nakuha natin. So, the value of your WU is equals to 2.47 multiplied by 3.91. So, WU is now equal to 9.66 kilonewton meter. So, eto na yung magsisilbing answer natin. So, ulitin lang natin ha. For the real hinge kapag uniformly distributed load, so yung value ng mga theta natin is equals to 0 sa real hinge. Pero sa plastic hinge, lagi tayong may value ng mga angles natin dyan.